Hello friends, welcome to CTC. Today we will see what is variable in Java. First of all, let's see what is exactly meaning of variable. In general, meaning of variable is not consistent or having a fixed pattern or liable to change, and of course unless it is declared as a final. We'll talk about the final keyword in later. But in general, meaning of variable, that is not fixed or not a consistent, liable to change. So let's see the definition of a variable. The variable is the basic unit of storage in a Java program, or we can say a variable is a storage location and has an associated type, sometimes called its compile time type, that is a data type, that is either a primitive type or a reference type. So as we have seen the primitive data types in previous video, non-primitive, that is nothing but the reference type. We'll see that in later videos. In Java programming language, the term field and variable are both used. So according to data types, there are two variables. Variables can be of primitive types, or variable can be a non-primitive, that is reference type. A variable of a primitive type, for an example like a variable of int type or float or double, may hold a primitive value of that exact primitive type. And in non-primitive type, a variable of class type T can hold a null reference. So reference type is nothing but if we create a class that is user defined type that can hold a null reference or a reference of an object or instance of that class. Same goes for the interface. We will talk about that interface later. Just for the time being, let's focus on the primitive variables. So actually there are 8 kind of the variables, but for the beginners, let's focus on the 3 types of the variables, that is instance variable, also called as a non-static field or non-static variables. Second is a class variable, aka static fields, and the third one is a local variables. Here we can see in the chart we have variable type, instance variable, static or class variable, and the local variable. So let's see declaration of instance variable. Instance variables are declared in the class but not inside the block or method or the constructor. So let's see, we'll declare an instance variable. Here we have a student class, that is a non-primitive data type. You can say user defined data type student, where I'll declare age equals to 24. So this is an instance variable. So here you can see in the scope of instance variable throughout the class, directly accessible into all methods, constructors, blocks, except static methods and static initializers, where you need to use instance of that class to access it indirectly. So first you need to understand that object, to access this age variable, we need to create an object of class student. Object is nothing but an instance of a class student. So here we'll create an object of student class obj1 equals to new keyword. You have to use this new keyword to create an object of class and followed by the class name student. So this creates an object of the class student. So here you can see that scope of that, this is out, age. If you try to access that instance variable directly inside the static method, that is static void main method, it gives compile time error, cannot make a static reference to the non-static field age. So to access this instance variable inside the static method, as you can see that scope, if you want to access that inside the static method and static initializer, where you need to use the instance of that class to access it indirectly. So to access this, you have to create an object. We have created obj1 dot age. So we'll run this. So you can see the output 24. Let's try to understand how it actually works. We have just declared and initialized an instance variable int age equals to 24. So we know that int is a keyword, age is nothing but an identifier name given to that variable, equals to is an operator used to assign a value to that particular variable, and 24 is the value will be assigned to the age variable of int primitive data type. So in the memory you can see that we have created new object of student non-primitive data type, that is the student class, and in the memory we get a location where this object is stored, and that location may have, I just assume that it might have 23876, it could be anything, just for our understanding I use that number. So this is the memory and this is the address of that memory. obj1 is a variable of non-primitive data type or a reference type, or we can say variable of student type. So in this case obj1 object stores the reference of that object, that is the address here where this object is located. So this object has a instance variable, that is age having value 24. So when you create an object of student class, that object will have instance variable, each object will have instance variable age initialized to 24. If you create another object named obj2, and if you create a new object of student and stores the reference of that object into the obj2, that will have its own separate instance variable named age having similar value 24. So each object of student class will have their own age instance variable. Now we saw we cannot access instance variable directly into the static method, that is into the main method. Same way you cannot access that instance variable inside the static block. Let's try to access that here, which gives compile time error, cannot make a static reference to the non-static field age, similar to the main method, static main method. So to access that you have to create an object and dot. See, now it's possible. Let's run this. It prints 24, this one and this one. So this way you have to create an object and use the object to access the instance variable inside the static block or static method. And if you want to access inside method, you can directly access that. See, for that you have to call the method using object get. See, this way. So in method and constructional blocks you can access it directly, but for static method and static initializers you have to use the instance of that class to access it. Memory allocation time, when you create an object of a class, that time the memory gets allocated, that is in the heap memory. Memory deallocation time, when an instance of the class no longer is referenced, means it gets destroyed or garbage collected, that time the memory also occupied by that variable gets deallocated. So memory storage location, heap memory, dynamic allocation. Default values of instance variables are data types of the variables they are declared of. For example, if you declare an instance variable of type int, the value will be by default 0 and for boolean will be false. Let's see with an example. If you won't initialize this variable, we'll remove this one or let it have this. Okay. And if you print age, as all of you know that in the data type video you saw that int has a default value 0. You can see here 0 is printed, and for boolean it's false. You can see false. Access modifiers. Instance variable can have different access modifiers, that is public, protected, and private. Ways to access: can be accessed directly, but for static method you need to create an object of that class and access it. So you recently saw that in the previous example we access that instance variable inside the static method as well as inside the static initializer, but for that you have to create an object of that class. Using that object you have to access, but in non-static block or non-static method you can access it directly. So next is static or class variable. Declaration of class variable: you can declare within a class with static keyword. You have to use static keyword while declaring a static variable, or you can also declare that in an interface, since interface has a public, static, final variables, as you cannot create an object of interface. But you cannot declare static variable inside the method, constructor, or block. Scope: accessible inside all methods. First let's see with an example how to declare a static variable inside a class. So this is the static variable name id. Let's try to print this in a static method. We'll access it directly using its name. Let's run this. You can see it printed 101. Let's create a method, non-static method named get, and we'll try to access it in that method. We need to call that method get. We'll run this. You can see it printed that id. So in non-static method it is directly accessible. Memory allocation time: when the class or an interface it is declared in, that is student in our case, is prepared and initialized, means .class file is loaded. When the .class file of that student class is loaded first time, that time the memory is allocated for the static variables. Memory deallocation time: when the class, that is the .class file of student, is unloaded, that time the memory allocated for that variable will be deallocated, means the will be freed from. Memory storage location: really I don't know. If you know, if any of you know that, means if you really have legit information or authentic information about that, please comment down below, because I don't really know that. Since heap is for the instance, variables or dynamic allocation of the objects, and I know that stack is used for the local variables of the method, as each method will have its own stack, and the local variables get stacked over there. So if you know about this, just give me comment down below. But in my honest opinion, I don't really care about the memory storage location, and also you don't have to know in that depth that where all this information gets stored, which memory heap or stack. So we actually don't need to know all these things, because we have a lot of things to know, so we don't have to go inside that. This is the job of the Java language developer. They will manage all these things. So let's go to the default values. It's similar to the instance variables, means int will have 0 and float will have 0.0, boolean will have false by default. So access modifiers for static variables declared in class are similar to instance variable, but for interface access modifier will be public. Let's verify that. We'll create an interface name my. If I declare a variable name marks here, and if I want to initialize as you know that is final, we have to initialize that. By default public static final 80 marks, and by default it's public access modifier. If I try to change that, it gives compile time error. Interface build my marks only public static and final are permitted. So the access modifiers for the static variable declared in the class are similar to the instance variable, but for interface it is only public access modifier. Ways to access: directly using variable name as we saw in our example, or with class name also, and we can also access that using instance of, or we can say object reference of class, but that is not recommended since it may fumble you while differentiating between the static and the instance variable. So let's see how we can access that static variable using the class name. We can access this using student dot. You can see here id is listed since it is a static. Run this, it got printed here. So this way you can use class name to access the static variable. Next is the local variable declaration within method, block or constructor, scope within method, block and the constructor. Let's see with an example. We'll remove this rest. Okay, here if I declare a variable name age equals to 24, it is accessible here but not here. If you try to print obj1.age, you can see that age cannot be resolved or is not a field. So if you type here age equals to 30, so this is not the local variable which is declared here, because the scope of this age is limited to this block only. The moment control goes out of this block, this age gets destroyed. So if you run this age is not the local variable declared here, this age is instance variable declared over here. So we'll run this so you will understand that. Get, first we called object, we called this get method, so that's why it got printed get 24, and later on we called obj1.age, this variable gets printed 30. So scope of that local variable within the block or the method or constructor, it is declared in. For constructor also you can see student, this is a constructor, int marks equals to 70. If you try to access here marks, is unknown, is not a field. You can print it here. It is known to this block only. The scope of this variable, local variable marks only this block, constructor block. We'll run this. Oops, sorry. So the moment we create an object, this constructor will get called and we'll print this one, and later on this one, 24h. See, marks 70 is known to this block only, and the moment comes out of this constructor, that gets destroyed, and after that we call this get method which prints this get 24. This way the scope of the local variable is within the method or the block or the constructor it is declared in. That could be, block could be static initializer or initializer. Memory allocation time when method, block, constructor is invoked. Here you can see the memory for this one gets created into the stack when this statement gets executed. It means when this statement gets executed and control comes over here, and this initialization statement, local variable declaration, and this is the initializer, gets executed. This line gets executed, that time the memory for this age having value 24 is created or located. Memory reallocation, when this print statement is executed and the control goes back to the main method, means comes here, that time memory gets deallocated for this age variable. Memory storage, stack memory, as each method has their own stack memory for storing the local variables. Default value, you have to initialize the local variables before using, they don't have default value. Let's see with an example. If I do not initialize this age, if I won't initialize this age, and if you try to access that, the local variable age may not have been initialized. This is the error you get at compile time. If you do not use that age or access that age within that block, that time it won't give an error, but the moment you try to access the age, it gives compile time error. Let's run this one, so you will get that. If you run this object, if you run this project, you can see there is no problem, but the moment you try to access that local variable which is not yet initialized, then it gives error, compile time error. So you have to initialize that. 24. Let's run this. You can see get 24 is printed. Access modifiers, there is no access modifier for local variables. Let's try to assign private, no, illegal modifier for parameter age. Only final is permitted, there is not an access modifier. We will talk about this later. So you cannot have an access modifier for the local variables. Ways to access, directly by name. Since there is no chance to access the local variable outside the block, so to access this age variable, you just have to use its name to access it, as we have done in our example. So this way, these are the just basic variable types: instant variable, class variable, and local variable. There are actually 8 kind of the variable types. Generally you would find most of the videos on the YouTube saying there are 3 variable type, but there are actually 8 variable types, and I will, since this is a beginner video, I'm not going into that detail, but we'll upload another video in advanced videos for the Java. In that playlist I will upload the detailed video of each topic I have covered in the videos for the beginners. So thank you for watching my video. Please do comment, like, share and subscribe for more videos, and would love if you comment down what you think about these videos and how I can improve. So this is the only way I can improve my videos. And if you have any topic or subject you want me to make a video on, please comment down. Thank you for watching my video.